Alright, so our next question comes from OHM 4.22a. Determine the continuous time signal corresponding to each of the following transforms. So, it wants us to determine the continuous signal, x of t, and we're given x of j omega. So the first thing that pops in your head is the equation x of j omega times e to the j omega t d omega, right? But if you actually look at your cheat sheet formula thing, you will notice that there's already something given to you for a similar version of this. Okay, so on sheet you have 2 sine w, oh it's not big W, it's little w, it's omega t1 divided by omega. Okay, so there's no need for this. We're going to use analysis by just looking at it, okay? So first, we know that if we take away the shift first, so we have 2 sine of 3 times omega over omega. Okay? So we know that T1 is going to be equal to to 3. So T1 is equal to 3. And I am so sorry I did not write what the actual x of t was for this. X of t is going to be equal to 1, 0. T is less than big T. T is greater than big T. Okay? So that's why your T1 is important, okay? So right now your x of t is equal to 1, 0. Absolute value of t is less than 3, okay? And 0 when t, absolute value of t is greater than 3. Okay? So that gets rid of that. Okay? So now you're left with a time shift of 2 pi, okay, to the right. So, when you're shifting in x of j omega, or the frequency domain, you can find on your sheet, where is it at here, just so I get it completely right. Frequency shifting, frequency shifts, are equal to e j omega naught t times x of t. Okay? That's what the frequency shifting does for you, okay? So right now, x of j omega minus 2 pi and x of j omega minus omega naught. So obviously you can tell that omega naught is equal to 2 pi. Okay? So you're going to plug that 2 pi into this omega naught right here. Okay? So your new x of t, you're going to be multiplying your 1, which your x of t is right now, by your e j omega naught t. Okay? So it's going to be 1 times e j 2 pi t, 0 when t is less than 3, when t is greater than 3. Okay? And that takes care of the frequency shift, and you're left with the original. Okay, so you are actually done. This is the final answer. And yeah, nothing else needs to be done. I'm gonna go over it just one more time so you can kind of get a better grasp on it. Okay, so the frequency shifting is different for when you have x of t and x of j omega. Okay, so you have to realize that there has been a shift in x of j omega to get this correct equation. Okay, not the e to the negative j omega t naught times x of j omega. Okay, and that's everything. Hopefully this video helped you. Alright, so the next problem that we're going to be doing is 4.22c. Determine the continuous time signal corresponding to each of the following transforms. So instead of giving us x of j omega in an equation form like a nice person, he's given it to us in a drawing, so we have to come up with our own equation for x of j omega. Okay, so this right here shows the magnitude of x of j omega, and then we're also given the phase of x of j omega. Okay, so let's go ahead and write our equation for x of j omega. So first, x of j omega magnitude is going to be first, so this is going to be 0, this is 1, so the slope of this line is a rise over run, which is going to be negative omega, okay? And then the slope of this line, rise over run, 1 over 1, is going to be omega, okay? So from negative 1 to 0 equals negative omega. From 0 to 1 equals omega. And then 0 equals other. Okay, we're going to turn that into a little table here in a second, okay? And then the slope of this is just negative 3 omega, so that's equals negative 3 omega, okay? Alright, so that's where I'm getting these values that I'm about to put in this table over here, okay? So equals negative omega, omega, and 0. So negative 1 less than or equal to omega 0, okay? And 0 omega is greater than or equal to, less than or equal to 1, and then other. Alright? I guess we don't need the equal to because that's incorrect. I'm pretty sure. Okay, so now our angle or phase for x of j omega is equal to negative 3 omega. So the value for any number that has a real and complex value comes from this. So x of j omega is equal to the magnitude of x of j omega e to the j of the phase of x of j omega. Okay? That's how you can represent any number given the magnitude and the phase. Alright, so let's go ahead and write x of j omega for, this one doesn't matter, but these two we're gonna write it for. Okay? So negative omega e to the j 3 omega, and then omega e to negative j 3 omega. Okay? So now that we have equations for our x of j omega, we need to find the inverse Fourier transform. We need to find x of t. Okay, and we already know what the equation of what the equation of the inverse Fourier transform is. X of t is equal to 1 over 2 pi integral of our domain, which we already know, but I'm just going to leave it right now. Negative omega e to the... I'm just going to write the equation out for you first. X of j omega times e to the j omega t with respect to omega. Okay? Plugging in our x of j omega, we got 1 over 2 pi integral. So from negative 1 to 0, the x of j omega that goes along with that is this. Negative omega e negative j 3 omega times e to the j omega t d omega plus 1 over 2 pi integral from 0 to 1, that's this one, omega e negative j 3 omega times e j omega t with respect to omega. Alright, so we can go ahead and combine the e's, and we're going to have to do integration by parts. Something that nobody likes to do, but it comes up a lot. Okay? So this is going to equal to e to the j omega t minus 3. And then this is going to equal w, or omega e to the j omega t minus 3. Okay, I don't know why I struggled on that. They're the same. Alright, so let's color code this for you. This is going to be red. U is equal to negative omega du is equal to negative 1. Okay? dv is going to be equal to e to the j omega t minus 3. V is going to be equal to e to the j omega t minus 3. And remember, we're doing with respect to omega, so it's going to be j t minus 3 on the bottom here. Okay, that is an ugly line. Okay, and let's go blue. Blue right here for this. Okay, so u is going to be equal to w, du is going to be equal to 1, dv is going to e j omega t minus 3. V is equal to e j omega t minus 3 all over j t minus 3. Alright, so let's do our integration by parts. Get this cooking, okay? 1 over 2 pi, just leave it out here. Just don't forget it at the end, okay? So we're going to have, first, for y'all who don't remember, uv minus integral of v du. Okay? I actually kind of wrote that for myself as well. So u times v is going to be negative omega e j omega t minus 3. divided by j t plus, or not plus 3, what am I doing? Minus 3. From negative 1 to 0. Okay. And then it's going to be minus. So I don't confuse myself. Du is equal to negative 1, and we are minusing. So negative, negative, so it's going to turn to a plus. Okay. From negative 1 to 0. Looks like a 6. 0. Omega. Or it's not omega, it's just going to be e j omega t minus 3 all over j t minus 3. Okay? Plus the blue side now, okay? So u times v is going to be w e j omega t minus 3 all over j t minus 3 from 0 to 1 plus, okay, so this one's not plus, this is going to be minus, interval from 0 to 1, e j omega t minus 3, all divided by j t minus 3, okay? So this gives us 0, and then this will give us a negative 1. So here, let's see. So for each 1 over 2 pi, so it's going to be positive, negative, negative 1, positive, because you're plugging in for omega. Okay, e to the j negative 1 times t minus 3. Alright, so almost messed up here. I'll show you guys what's happening here. So first we're going to have a 0 minus negative, negative 1. Okay, so there's 3 negatives, plus, plus, still left with negative, okay? Plus e to the j omega t minus 3 all over j squared is going to be negative 1 times t minus 3 squared. Okay. Plus this is going to give us a 0. This is going to give us e to the j t minus 3 over j t minus 3 minus e to the j omega t minus 3 all over j squared is negative 1, negative t minus 3 squared plus, plus, and this is going to be from negative 1 to 0, 0 to 1. Okay? So, this is going to be a 1 over 2 pi integral of e negative j t minus 3 plus, oh guys, do not forget your jt minus 3. Whoops, that would have been bad. Jt minus 3 plus, this is going to give us 1 okay, so plus 1 minus e negative j, oops, there's no more omega left. Negative j t minus 3 all divided by negative 1 times t minus 3 squared. Okay? Plus e to the j t minus 3 j t minus 3 plus, that's going to give us 1 e to the j t minus 3 over t minus 3 squared minus 1 over t minus 3 squared. Alright. So I'm already seeing some groupings that are going to make a, I think it's going to be so one's going to make a cosine. I can already see it. And I think I see one that's going to make a sine. This is what you need to be thinking about when you have to do this god-awful integration by parts. It's going to simplify down to something nice-ish. Okay? So, we're going to get rid of this negative on the bottom, turn that to a positive, turn that to a minus, turn that to a positive. Okay? So I'm already seeing that e to the j, so we're grouping these right here. I'm going to change this color. So we're going to group these into one to try to make it a, I don't know, it's probably going to be cosine. E to the j t minus 3 plus e to the j negative jt minus 3 all over j t minus 3. Okay? Nope, that's wrong. Because I know what I just did. Forgot the negative right here. Okay. So as you can see, when you try to group those two, that's going to make a sine. Okay? So e to the j t minus 3 minus e to the negative j t minus 3 all divided by j t minus 3. Remember, all this is 1 over 2 pi as well. Okay? Because guys, remember the negative sign I didn't bring down. Okay? So let's see if we can continue this. So then, we have e to the j t minus 3 over squared. Okay, so we can also group these right here. Alright, because they have the same exponent and same denominator. Okay. Go ahead and sew that up. Plus e to the j t minus 3 plus e to the negative j t minus 3 divided by t minus 3 squared. Okay. And then our last grouping is our individual ones, which both also have the same denominator and they're both -1. So minus 2 over t minus 3 squared. Okay? And this is all multiplied by 1 over 2 pi. I'll do the brackets just so you don't get confused. Okay? So, it's looking better now. So now this, all of this, that's going to be equal to 2j sine of t minus 3 over 2 pi j t minus 3 plus all of this is going to be a cosine, so it's going to be 2 cosine t minus 3 all over 2 pi t minus 3 squared minus 2 over 2 pi t minus 3 squared. Alright, let's go through and cancel. Yaga, cancel, 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 cancel. Alright, so your final answer should be sine t minus 3 or t minus 3 plus cosine t minus 3 over t minus 3 squared minus 1 over t minus 3 squared, squared. And then I factored out the 1 over pi to make it the most simplest form. And guess what? You are done with the awful integration by parts. Okay? So, the main important part of this question is knowing how to go from the graphs that he's going to give you, okay? It may be an x of t graph that he gives you, and you have to make it's like your step function brackets over here, or he'll give you the x of j omega, and you have to know how to change it to an equation and go from the graph to the step function to the equation, and then plug it in to the integral. And then obviously the integration by parts is by far the hardest and longest part of this problem. This other part is pretty easy once you get enough practice. Okay, so if you have completed this,